Good morning and welcome back to our regular class. Till today we learn about the different properties of acid, base and salt and their uses too. As a reminder, we learn about what is acid, what is base and what is salt. That is acid, the substances which gives H plus ion when dissolved in water. Similarly, bases OH minus ion when dissolved in water, and bases are categorized as base and alkali. That alkali are water soluble bases which give OH minus ion, and the metallic hydroxide. Metallic hydroxide or oxides are termed as bases. So, from that point we noted that all alkalis are bases. All alkalis are bases, but all bases are not alkali. That is, all bases did not dissolve or need not to be dissolved in water. Similarly, another one was salt. That salt is are those compounds which when dissolved in water gives positive ion other than H plus ion and negative ion other than OH minus ion. We discussed about the different uses of acid, base and salt, and in today's class we will discuss more about indicators. So, the indicators means those substances are those useful substances which indicates whether the given substances are acid, base and salt. So, from this slide, today we will start from this slide, that indicators. In the figure we see that lemon piece and baking soda. There a piece of paper showing red color and blue color indicates that the given substances is whether acid and base. From our previous class we learn about that lemon is from the citrus family, so contain the citric acid. So, litmus paper, that indicator is litmus paper. You can see in the slide, that is litmus paper turning red when tested on acid. That means the color of litmus paper is changed into red when dissolved in acid or when it is mixed with acid. Similarly, when the litmus paper is dipped in the base, then it will change into the blue color. It is shown clearly in the figure. Now, see, similarly another type of indicators are phenolphthalein and another one is methyl orange. There you can see acid. The color of phenolphthalein does not change in acid, while in alkali the color changed into the pink color. You can see in the bottle or round bottom flags, you can see in the round bottom flags the color of alkali is changed into the red color due to the presence of phenolphthalein, where the color of acid does not change. Similarly, you can see in the next figure, that is methyl orange, another type of indicator. That indicates the given substances whether acid and base, red and you can say yellow color, red in acid and yellow in base. So, it is easier to indicate the given substances. Similarly, there are the different useful indicators, but in this class we will only discuss about these three types of indicators along with the universal indicators. And the term universal indicator is different from the indicators. Let differentiate it. Indicators means those substances which indicates the given substances into acid, base and salt or neutral substances, but universal indicators identify or indicates the given substances along with their strength, So, there is a comparative figure. You can see the comparative figure of litmus paper and universal pH paper. That is, universal pH paper means universal indicator. We will discuss what is pH about in later classes. So, there acidic solution. In acidic solution, the color of blue litmus paper change into the red. Note this point. In the acidic solution, the color of blue litmus paper is changed into the red color, and similarly in the basic solution, the color of red litmus paper is changed into the blue color. And you can see in next figure, there is universal pH paper dipped in the basic solution. Universal pH paper dipped in a basic solution. There the solution changes the color of pH paper according to its pH. Here I am using the word pH or terms pH. pH means percentage of hydrogen ion concentration. The percentage of hydrogen ion concentration in the given solution. There the blue color indicates its pH is 12. The blue color indicates in the basic solution its pH is 12. There you can see the figure, like for the neutral color there must be green color, for the neutral substances there must be green color, and for the acidic solution it start from red to yellow and slightly green, and then for the neutral solution it start from green to the dark blue, and the pH ranges from 0 to we may say that 1 to 14, it also ranges to 0 to 14 also. So, we can categorize the strength of acid and base according to the color. We can identify the strength of acid and base according to the color. So, this is the good advantage. We may say that this is the beauty of pH paper. Without any instrument, a single paper can identify, a single paper, that is pH paper, can identify the strong or strength of acid, base along with this indication. So, here now we discuss about indicators that which we already described, that is indicators, the chemical compound used to identify whether a given substances is acid, base in nature. The most commonly used indicator are litmus paper, phenolphthalein and methyl orange. These indicators are commonly used in our lab and easily available. So, here in the table you can see blue litmus paper, in acid it changes into the red color, base no color change, salt no color change. That means, blue litmus paper only indicates or only identify the acids, it changes the color into in the acid into red color. Similarly, red litmus paper, it changes its color into base, in the base into blue color. Red litmus paper changes its color into blue color in basic solution, whereas no change in acid and salt. Similarly, methyl orange, red in acid, yellow color in base, no change. Phenolphthalein, no change, pink color and no change in salt. Purple cabbage juice, which we can make in our home too, that is red color acid, green color base, salt, purple color, means we can say that no change. And a question arises like that, why phenolphthalein is not used to indicate the acid? Because it does not change in color in acids, it only indicates the pink color, indicates the base by changing the color into pink. Remind this point, phenolphthalein pink color, phenolphthalein pink color into the base, methyl orange red in acid, yellow in base, red litmus no change in acid, blue in base, blue litmus red in acid, no change in base. Again I am going to repeat this, blue litmus red color in acid, no change in base, red litmus no change in acid, blue color in base, methyl orange red color in acid, yellow in base, no change in salt. Similarly, phenolphthalein change of color in only alkali or in base, that is pink color, and no change in acid. Similarly, for purple cabbage juice, red color, green color and purple color respectively, acid, base on salt. That is in this figure you can see like phenolphthalein, methyl orange. Phenolphthalein you can see acid, alkali, pink in color, no change in acid, methyl orange red or orange color in acid, yellow color in base, and you can see that is litmus. We already discussed about that litmus paper, that is the change of color in different solution or solution state. Here you can see that is blue litmus paper. Blue litmus paper when dipped in acidic solution change into the red color. Similarly, red litmus paper when dipped in basic solution change into the blue color, and another one is universal pH paper, we will discuss about it. Now, indicators, there are the three types of indicator which are commonly used, that is litmus paper, phenolphthalein and methyl orange. Now, home talks, there is, you can easily prepare the simple indicator in your home too. I have figured out some ways how to make the indicators. Like for preparing the simple indicator, take some rose petals and crush in the mortar or pestle, then mix alcohol to dissolve the plant pigment, that is different organic substances present in the plant is easily soluble in alcohol, which and the process is called extraction. There from the extract, that extract you can make the filter indicator, that is after the extraction dip the filter paper or strip of filter paper into it and let them to dry and perform the test for the substances like lemon, soya sauce, baking soda, which are easily available in our home. Again, for this process you can use like take some rose petals with a little bit sand in a mortar and crush them with a pestle. Now, mix the alcohol to dissolve the plant pigment in it, that is the process is called extraction, and filter the mixture and soak the pigment in the strip of filter paper and let them to dry. And last one, perform the test whether your indicator is made or not, that is perform the test for the substances like lemon, soya sauce, baking soda, which are easily available in our house. This is the simple home task for you too. Now, we are discussed about the universal indicator. What is indicators? Indicators are only those substances which only identify, but universal indicators are the mixers of ordinary indicators. Universal indicators are the mixers of ordinary indicators which is used to determine the strength of acidity or basicity. That means, by using the universal indicator, not only the substances is given acid, base or salt is identified, along with this the strength of that substances used can be identified or can be known. That is the beauty of universal indicator. And by using the universal indicator, we can easily use or we can easily find the pH also. Then what is pH? pH means the percentage of hydrogen, present in the given solution, and its value ranges from 1 to 14. Its value ranges from 1 to 14. In board, I am going to make a pH range and we will discuss more about it. Please show the board. Seven, 1 and 14, that is pH means percentage of hydrogen. Or we may say that is hydrogen ion concentration in the given solution. pH is always inversely proportional to the concentration of hydrogen ion given in the solution. That means, if more concentration of hydrogen ion, the pH will be less. If there is more concentration of hydrogen ion, the pH will be less. So, for more acidic and for more basic, and this is for neutral, basicity increases and this one is acidity increases. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, which one is more acidic? Having the substances pH 1 and 4, having the pH 1 and 4, which one will be more acidic? Obviously, one will be more acidic than the substances having the pH 4. less acidic, which can be explained by this relation. For the strength of acid, the more stronger will be acid, more strength of the acid means needs more concentration of H plus ion in the substances or in the solution, we may say that in the solution. More the concentration of hydrogen ion, from the first definition, very beginning definition of the hydrogen acid, we define the acid as those substances which when dissolved in water must furnish H plus ion. Those which furnishes more H plus ion, more stronger means less pH. More stronger means less pH, and reverse, which have less H plus ion concentration or weak acid. Weak acid means more pH. Remind this point, H plus ion. So, the strength of acid can be easily found on the basis of this pH scale, that is 1, 2, 3, 4, 5, 6, 7 on down to the earth, in descending from 7 to 1, the acidity nature of this acid increases. Similarly, from ascending from 7 to 14, basicity increases, and for the 7, that is neutral substances, 1, 2, 3, 4, 5, 6 for the acid, 7 for the neutral. From 7 to 14, that is for the base. The number of pH determine the strength of acid. Here in board we describe the various points here, Now look at the slide. Slide please. In slide we describe the universal indicators and the pH range. Here you can see that the universal indicator is a pH indicator which is made from the different compounds that exhibit the several smooth color change over a wide range pH value to indicate the acidity or alkalinity of the solution. That means it is a mixture of different indicators. It does not only change the color, but it also shows the strength of given substances. There in the figure you can see that the pH range is in the down, there is pH 1 to 14, and above there is the strength, that is very acidic, slightly acidic, neutral, slightly alkaline and very alkaline, and see the color and number aspect. That is 14 purple, it is very strength alkaline solution, 1 red, it is very strong acidic solution, green for the neutral one. There you can see the pH scales of different food materials which are different substances which we used in our daily life. Let us see that gastric acid, the acid HCl, gastric acid means the acid HCl which is produced in our human stomach daily is HCl, it has pH 1, means highly acidic, that highly concentrated hydrochloric acid is being produced in our human stomach daily. Next one goes to lemon juice which we used, then for the apple juice, tomato juice, black coffee, it is still acidic, it has pH 5. Similarly, for milk, it contains acid and the pH ranges to 6. Similarly, for pure water 7, it is neutral. Then for the egg, it is basic, pH 8, and in between 7 and 8, 7.4 is the pH of human blood. 7.4 is the pH of human blood, that is our human blood is also slightly alkaline. Egg alkaline, baking soda 9 alkaline, and soap 10 alkaline, ammonia solution 12 alkaline, bleaching powder, that is 12 alkaline, then are the concentrated solution of alkalis, they are 13 and 14. From this table we are I think we are very clear about what is universal indicator, what is pH scales, what are the pH range, what does pH range stands. These figures makes us clear about the pH range too. Okay students, in coming classes we will discuss more about the another chapter of the chemistry of class 8. Till then,